the recording, guys. Is it 7th or 8th? Anyways, so today we are going to cover the RAG. Okay, in the last session, we talked about how to create a RAG pipeline for unstructured data. But that data, and we also created, we used a very simple PDF file, which was having only and only the text. But the real data in real case scenarios, what will happen is the data is not going to be that simple. It does not consist only with the text. So the data, which for the applications which we build for the different clients may have different kind of data. They may have tables, right? For example, in the PDFs or in the Word files, all these are again unstructured data. We can have Word files, HTML files, PDF files. But on top of that, not only they will have text, but they have more complex objects like they can have tables, they can have some graphs also, right? They can have different, I mean, plots also and images. So how we will deal with that kind of data, this is what we are going to study. Okay, so this pipeline is also going to be almost same. The only difference is that is this ETL pipeline. Okay, so what we need to do is we need to extract the information, we need to transform, and then we need to load it. Okay, so the main challenge is going to be here. How we can extract the text part of it, how we are going to extract the images, how to extract the uh, tables as well. Okay, so this is where our main focus will be. Okay, so largely there are actually multiple techniques. Okay, there could be numerous ways to accomplish this, but we will be focusing on one of these techniques. Okay, so the first is like multimodal embedding for all the elements. So what does that mean is what we can do is our model, right, which we will use to create embeddings is so what is embedding model, by the way? So embedding model is also a model, is also a neural network which has been trained, right? So in the last session we used embedding model which could understand the text and which could create the text embeddings. But if you have to deal with such data which is multimodal, which is having images, and in fact this goes to audio and video as well. So if our input data is having, all this complexity and the data is complex, what we can do is one way is to use multimodal embedding models. Okay, so those will be the models basically which are trained in such a way that even if you give them an image, what they will do is they will create some embedding out of it. Okay, so this is the first option. The model will be able to vectorize your text, your images, and everything will go into a single vector space. In such a vector, the vectorized image of the Lord Ram. So this is an example. Let's say in the form of text, we are talking about something about Ayodhya, or maybe, how the Lord Ram uh, had a fight with Ravan and he came back to Ayodhya and things like that. If you have that kind of text, and with that text, we also have a picture of Lord Ram. So what will be done is once when the embedding will be created, the embedding of this image of Lord Ram will be very close to the embedding of your text, which is talking about Ayodhya or maybe Lakshman or maybe Sita. Are you getting the context?
Yeah, Surendra, here in this case, for this
Mhm.
images, do we have to provide a tag or label that what
No,
that
no,
image represents?
No, no, nothing will be provided because this multimodal embedding is sufficient enough. It's already so trained that even if you give it an image, it will read that image and it will create some embedding, right? Some
Okay.
embedding which will be close to the embedding which it will create for the text which is talking about Ayodhya or Sita or Lakshman or Ravan.
Okay.
Okay.
Or
In
we
that,
take example of some brochure where the
Mhm.
product is given and the details are given about the product.
Exactly. So if you have a brochure where we are talking about the Nexon, right, the
Yeah.
features of the Nexon car, and on the next page, if we have an image of the Nexon car, okay, so image of the Nexon car, I mean, if it is written somewhere that it's a Nexon, then I think it will be able to create embedding which is close enough to the Nexon specification. Okay, but I think you got the idea, right? So in this case, our we have to choose correct or multimodal embedding, right? For example, we have something called the clip. Okay, so clip embedding model is from the OpenAI. If you want to accomplish this complex data, if you want to create embedding of such a complex data, and if you want to choose this approach, what you can do is you can choose this clip model. Okay, at the vector database side, I don't think there is going to be any change because vector database is anyway is a special database which has dimensions like 1000, 1500, or maybe 3000. End of the day, the image or the text is going to be converted into numbers, right? If you are having the vector database of 1500 dimensions, then there will be 1500 numbers or coordinates which will represent that image. Similarly, if you have a text, the representation will again be a vector which is having 1500 different numbers or coordinates. Okay, fair enough. So this is the one of the option. The second option is depending on the document, what we can do is convert entire pages into images and we can pass them to multimodal large language models. So these multimodal LLMs, right? For example, we have models like GPT-4o, we have Gemini. So these models are known as multimodal models because they can understand the text. They can also understand if you pass them the image, then they are trained in such a way that they can do the OCR of the image and they will understand the image by reading its content also. Okay, so the second option is directly passing your converting your all the pages into images and then sending them one by one to your multimodal LLM, which can read the entire content out of it. Okay, so let me read it out. Sometimes you will have to try a more brute force approach. In those cases, you may have to treat entire page of a given document as an image. This might be particularly useful when you have entire pages that cover a single topic, like big tables that might make it harder to partitioning models to extract data from them. Then you would combine this method with the previous method to summarize and vectorize it. Okay, so this is the second approach where we are passing page by page and treating them as an image to the multimodal LLM. And then what it will do is it will create some summary out of it. Okay. The third option, which we will use, we will do one exercise, is the third option, where what we will do is we will summarize multimodal elements, extract and summarize each multimodal element. So in this method, what we will do is let's say we have a PDF which is having tables and images and other complex objects. So we will pass that to some APIs, which will do what? It will create different elements out of it. And then for each element, those elements, let's say we have one main element as an image, the other as an table, and third as in text. And then what we will do is we will create summaries of each of those objects. And we will link those summaries with that particular content. Maybe I will go to the next page. It will make more sense. Okay, so we are going to use one such API which will help us to do uh, the the extraction, which is called as the unstructured.io. Okay, so what it will be do, let me show you on screen. Unstructured.io. So this is a third party API. So this gives us the mechanism by which we can extract the information out of our document. So it has actually a couple of options. Okay, what it does is it provides us the platform also, so that you can use its platform, and then you can use it like pay as you go to the platform for transforming your unstructured data into the data that is readable or RAG. Okay, so they provide that platform itself. Next is API. We can develop our applications at our end, but what we will do is when we need to convert or extract the elements, when we need to extract the elements out of my PDF, I will call this API. And this API will do what? It will take your documents as an input, it will do some processing. And in fact, this API also uses large language models in the backend. It will do some processing and it will return you the past information. Okay, but there is another way which is called open source, which we will use. Okay, we will use this method where we will download and install the unstructured.io library, and then we will be able to fetch or take out the different elements out of it. Okay, so these are the three ways: platform, API, and open source. We will be using open source method where on our laptop or maybe on the Google Colab file, what we will do, we will download its library and we will use it to extract the different elements. So what it will do is this API will help us to fetch the tables. There will be an table element, there will be an footer element, there will be an image element and things like that. So we will do this exercise today. Okay. So this is called the partitioning actually. Partitioning function is in unstructured API allow users to extract structured content from raw unstructured document. These functions break a document into different elements. As I said, title, narrative text, list items, and others. Okay. So what kind of file does it support? Your input file can be .csv, it can be .eml, message. It I think supports lot of formats, right? PDFs and message, MD, RST, RTF. All these formats are supported. If your data is lying in any one of these files, this unstructured API does support that. We will use partition PDF. The partition PDF function. So we'll let me go back to the slide.
So
Okay.
Surendra, the
Hmm.
unstructured IO is a kind of an example provider of the multimodal embedding model. Sorry, multimodal embedding model, is that?
No, no. So it's a provider which basically parse your input and complex documents. Provides an API, or it will provide a platform and also in the form of API or in the form of library. If you use this platform or API or library and use it, what it will do is it will parse your input PDF or docs files into different elements so that you can work on those elements. Okay, I will tell you the entire strategy,
Okay, okay.
how we will do it step by step. But I'm just telling you these are the three different offerings from unstructured.io, hosted platform which is used for enterprise clients, serverless APIs where you simply send your documents and you get back the extracted data in a structured format. The name itself is the unstructured.io. It takes the unstructured data as an input and it turns them into structured data. Okay. Open source library, this is the one which we will be using. It runs locally and you will need to install a few packages to make sure ML models can run locally. Performance is not as good as API. Definitely, this is the best. This is one notch down, and this is, I mean, this is not that super. Okay. So if you want to use it for your enterprise level, I think you have to go with the first or second option. They also have integration with the Azure and AWS. Even it provides its service as a, it is provided as one of the services on these cloud platforms also. Okay. So let me go through what is our strategy. So how our pipeline will look like for the multimodal documents, we will have these input documents. Okay. As I said, there are number of formats which are being supported. So if you choose any one of those documents, what it will do, we will, sorry, let me take the highlighter. Okay, so these are our input documents. Then we will use our unstructured API. That can be unstructured library, API, or platform. And with the help of that, what we will do is we will extract the images separately. Okay, whatever images it has, we will pull them, and we will also stack all the tables which are present in the document and whatever text we have. Okay, so we will create three categories of these list basically, or arrays. One will be image array, the other tables array, and third is the text array. Then these images, tables, and text will be passed to the large language models, LLMs. Okay, so these two, tables and text, can be passed to your normal large language models for creating summaries out of it. Let's say there is a table which is having information about, as we said, maybe about the Nexon model Creative Plus. Okay, so that table had all the specification of that model of the Nexon Creative Plus. So we will send that particular table to the large language model, and the LLM will read that particular table, and it will create one summary out of it. Okay. Third is the text. Text, I mean, as we have done, text will be passed to the LLM, and it will create one summary out of that text. Third important thing is image. If we pass our image to our normal LLMs, which are not multimodal, then it will not work. So this time we have to use one multimodal LLM, which will read these images and it will create some summary. Okay. So now at this step, we have the image and the summary, the table and its summary, and text and its summary. Okay. Next, what we will do is we will associate these images with these summaries. Okay. That will be done with the help of doc ID. So we will create one unique identification with the help of which we can associate each element with its summary. For example, this is an image of Lord Ram. We will have some summary that this is Lord Ram. Okay. If we have a table which is having some Nexon data, it will create some summary. This particular Nexon model has this fuel efficiency, the price band is so and so, what all features which are there in the table, they will be extracted as a summary. And similarly, the text will get a summary. Now our next step is we will use one embedding model. Okay. This embedding model, in this model, what we will do is yeah,
Sorry. So summary is in text format,
text format.
even image summary also in text.
Yes, yes, yes. Okay.
Okay. Yeah.
So then what we will do is whatever embedding text embeddings which we have created, these summaries, they will be converted into text embeddings. This we have already done, right? We have been creating embedding out of the text, right? So now this has become normal RAG of a normal text, which is clean, because we have separated our multimodal data out of it. Image has been taken out, table has been taken out. What we have done, we have created their respective summaries. And for these summaries, we will create the embeddings, the text embeddings, and we will put it in our vector database. So only summaries will go into our vector database, not all the other multimodal items. They will go into a separate store like document store. Okay. So what we are doing is we are saving our summaries in the vector database, whereas all the rich media like image tables and all other things will go into a separate store, which is a document store. So this is not a vector DB. Okay. Now when the question will be asked, it will hit our vector database, which is having all kind of summaries. It has the information of Lord Ram. It has the information of the story of the Ram. Okay. And maybe in the table, we have some data about Ram, Lakshman, and all those characters. Okay. Now we have all the information in the vector database. The query will do the search, and it will create top 3 summaries based on semantic search. And what will happen is since okay, one thing we have done is these document IDs are stored. When we create these embeddings, we will save these document IDs in the metadata of these embeddings. Are you getting? So for the summary of this image, when we are creating embedding, we will save the document ID in its metadata. Right? We have seen earlier, right? Whenever we are creating chunks of our text, we also have some metadata like what is the document title, what is the document page number. Yes, all those
Yes.
informations are stored with the embeddings in the embeddings metadata. So this time in the embedding metadata, we will explicitly save these document IDs. So when the retrieval take place, it will fetch these summaries from the metadata. We actually know what is the document ID, and with the help of that, we will fetch those documents or I mean, whatever elements which are associated with these summaries, they are also pulled from the document store. And what the user will see is basically these things, not the summaries. Okay, the summaries will only be used to associate document IDs and for the retrieval part. But when the user, when the final answer will be created, it will basically pull all these elements which were associated with these summaries.
So Surendra, this in document store, we will store like document ID as well in store, document store,
Yes,
doc ID
yes, yes, yes.
In,
It will be stored.
in both. Okay,
Then only we will be able to search by document ID, right? It
in
will
like in
have,
both the places,
yeah, yeah.
in vector DB and in document store. So
Yes, in
based
the
on
back.
that, it was okay.
Exactly. So in the metadata, we have this doc ID. Here also we have like doc ID number 1. It has this image. Okay. Some image doc ID 2. It has some table. So when we know the document IDs from the summaries, we will make a search. Okay. Find out all the elements which is having doc ID 1, doc ID 2. So it will fetch all those elements.
so this document store is kind of the part of the NoSQL database. Is that correct?
Yes. Yes.
Oh,
Yes. Correct. Correct.
So if you are creating summary, so information can be lost also, right? Meanwhile, because it is just a summary of image, not complete information about image.
No, I mean, if you have an image, right? If you have image of Lord Ram, then whatever summary you will create, right? I mean, how how the information will be lost, right? Even if you send this to directly multimodal LLM, then only it will create some kind of summary, right? Which will describe this image, right? If this is an image of maybe of the Kumbh Mela, then whatever information it has, like whatever information is there in the image, maybe people are taking holy dip in the river, or there is a Ganga river flowing. So whatever summary it will create, that will be stored. I mean, anyway, the search cannot happen on top of image itself, right? You have to create some caption or some text out of it, then only we will be able to do the search on top of it.
Yes.
Okay, so this is what our strategy is. I was trying this code yesterday, but it was not working 100%. But let's try one more time. This is 25th, yeah. Okay, so there are actually a lot of libraries and lot of conflicts which was happening. Okay, so let me try. So this is multimodal RAG with the LangChain, and these are the dependencies. We need to install some popular utils, Tesseract OCR, and other libraries. Let me run this one. It was creating some exceptions. So as and when I was getting exceptions, I was, doing some Gemini search, and it was saying that install this, install that. So that's why I'm have these installations one by one. Okay, so let me show you this library one more time. So what we have is this unstructured all documents. Okay. So either you can use all documents. When we use all documents, that means your source document can be anything. But if you are using like only PDF, you are sure that your input is PDF, then you can just install the unstructured PDF library. Okay. So that is what I was trying to convey. This is for docx. This is for CSV. So like that, they have different libraries. But if you want to install all of them, you can simply give this one, all docs. That means it will support all the formats. We will be using Chroma database, okay, for our vector database. And then here as shown in the picture, what so these two models, we will use Grok models because we don't need multimodal. For this one model, which is basically creating captions for summaries for the images, we will use Chat GPT, GPT-4o basically. Okay, and this is going to our Chroma database.
Do we have an open source, the multimodal
No,
the LLM?
I don't think we have. Need to check actually. Need to check. I'm not sure if these llama models are multimodal. I don't think they are. But yes, yes. I think there is one model, one llama model, which is llama vision, I suppose. Let me llama vision model. We are releasing llama 3.2, which includes small and medium sized LLM text only model. Lightweight and multimodal llama models. These are lightweight. So, I mean, definitely you will get, I think.
Okay. It's multimodal, right? At the top.
Yeah. They are lightweight actually. So maybe some bigger models you can also get. I think Llama Vision is research products, Llama. 3.2 11 billion vision. Oh, Llama. Yeah, these are 3.2 11 billion vision model. These you can also use.
Okay.
But I will be using this OpenAI.
Okay.
Then this LangChain.
And coming to the document store, which one we are going to use?
I think it's going to be in memory document store.
Okay.
The documents stored in memory and with the indexes also, which called the doc ID.
Yes.
Okay.
So, okay, so I will set all my keys here. Extract the data, extract the elements of the PDF that we will be able to use in the retrieval process. These elements can be text, images, and tables. So what I will do is I will take this attention. I think I downloaded yesterday itself. Should be there. Okay, let me browse attention. So this is that attention PDF, right? I think you all must be aware of. Let me open also this one. Okay. I have browsed and kept this attention.pdf. So what this is having is this is having all the flavors. Okay. So we have like this text, we have some footers, we have some headings. Okay. We will have these images. Okay. And these are the also images, some formulas, and these tables. I think this is a perfect example of complex documents. Okay. Let me get back to.
So Surendra, like you are
Mm.
like we are reading tables. So how it will be reading like row wise, or how that context would be
Yeah, so I mean,
different?
what it will do is it will read those tables. This library will take the entire table element. It will identify that okay, the table is starting here and it is ending here. Then it will scan the entire image and then it will create one HTML formation of it. Okay, it will convert. It will read all the lines of that table and it will create one HTML file out of it, which we can use to create summaries.
So
Okay.
entire table would be converted at once, like not like
Yes.
we convert into embedding, so we give some overlap or something.
No, no,
It's
no, no,
not like
no, no.
that.
This is what it will do. Na? It will parse the entire PDF into different elements. It will say, this is my first header. It will say, this is my second table. Second element is a table. So it will take the entire table as one element. It will not fragment that table. And then it will read the content of the table and it will create some HTML, HTML rows and HTML headers kind of thing, so that it can represent the entire tabular data in the HTML format. Okay.
That is the summary that you meant in.
And then that text will be used to create the summary that LLM
Okay.
will create, right? Large language model will create the summary.
Okay.
Okay. So we are right now here. We are extracting this unstructured will create, you will parse the PDF and it will create image element. Maybe it will say, I have found 10 images in this document. I have found 5 tables in this document. And then I have found these narrative text. Okay, like it will make a list of all these things. And then we will pass all these elements to the LLMs to create the summaries out of it. So that table will be converted into HTML and then that text, HTML text will be sent to the LLM to get the summary out of it. Okay. Let's see if it runs or not. I had couple of exceptions here and there. So, okay, so my first thing is I have browsed this attention.pdf file, which is having all flavor of data, and I'm setting this path and all. By default, this everything is in dot content. Okay, so if I say less, it is attention.pdf is in my current directory. Okay, if I do something like if I click here now. So these are so this actually this Google environment which we are seeing right now. This is one Linux machine. Okay, and we are creating one temporary session that with that particular Linux machine, Unix or Ubuntu, I think. Okay, that which is there at the Google platform, and these are the different folder structures in it. Okay, so in this content folder, we have all these files. By default, when we open Google Colab, we are in the content folder. Okay, so we have placed our attention.pdf file in it. So these are a couple of libraries. Now, okay, now let's go through this particular text, which is very important. What we are doing is from unstructured dot partition dot pdf, we are importing this partition underscore pdf. Okay, because this everything which we are talking about falls under the partitioning basically. Okay, this library actually does give lot of functionalities. You can use this unstructured.api for cleaning also, for extracting, for staging, for chunking. So there are a lot of use cases for which you can use this particular library. But what we are more interested is we are more interested in partitioning. Okay, so whatever which we are doing is fall under partitioning. Partitioning function in the unstructured allow users to extract structured content from a raw unstructured document, and it will break a document into elements such as title, narrative text, list items, and others. This we will just see. Okay, so this is the import. This is the path which we are giving our file, and here we are creating the chunks out of it. So when we use this partition underscore pdf function, what we are passing it the file name, the file path, and the other important is infer table underscore structure. If you need to extract the tables, what we will do is we will make it true. And when we are making it true, that means we are saying we need to extract the tables. At the same time, we have to change our strategy to hi underscore res, high resolution or something, I think it means. So this will help us to extract the tabular information. This strategy can have three different values actually. There are other values like fast or okay. I need to search in the documentation. So right now we are using its high resolution. Whenever you need to extract the table, you need to use strategy as high res. This is very important. Second is extract image block types, image. Add tables to the list to extract image of the tables. If you want to create images also out of the tables, then we can also give it like tables. But this is not what we want. What we want is we want the tables to be extracted separately, and only the images will be extracted as images. We don't want to convert tables into images, right? So that's why we are just giving the image here. And what we can do is if you want to store your images, all the images which are there in your PDF into your local path or somewhere, then you can use this one also, right? Image output directory, and you can give some output directory where it will pull all the images and it will store it for your own temporary purpose. Okay. Otherwise, what it will do is it will just pull the images. It will keep it in memory only. But if you want to save it, then you have an option. Third is extract image block to payload. Okay. If true, will extract base 84 for API uses. So what it will do is when you create images out of it, when you pull images out of it, it will convert those images into base 64 representation. Okay, it will convert its format into base 64, and the base 64 format actually we can display on our Google Colab also. Okay, so I have written a function also which will help us to display that image on our Colab. Okay, so this is for that conversion image into base 64 representation. Final thing is chunking strategy. So what should be our strategy when we chunk it? Okay, let me do one thing. Let me comment this. Sorry. Let me comment this block, and this is, I mean, there is one more which is extract images in PDF, which we have already used, right? So this is been deprecated actually. So if you see this kind of thing, then don't get confused. This was the older way, to say that we want images out of the PDF, the latest way is infer tables structure. Sorry, this one, extract image blocks. Okay, so this is just for your information. Don't uncomment this one. So I'm just commenting these 4 lines and then just see whether it works or not. First of all, it will take some time, right? Because what happens is when we download all these libraries now, when we install these libraries, there are machine learning models or things like that, which will take your content and it will try to do OCR, right? It will read character by character and it will then create those elements. So this will take some time. See this YOLO X, right? If you Google what is YOLO X, a real-time object detection model, basically. Okay, from the YOLO family. So YOLO family, these are the machine learning models which are used to detect the objects and to identify the objects in an image. Okay, so there are a lot of things which are going in the background since we downloaded these libraries. If you are using API, the same thing will happen, but it will happen at the server end. We will just send our document or the PDF as an input, and all the heavy lifting will be done by the API provider. They will convert everything, and then whatever the final elements are there, they will send it as a response. But right now, everything is happening on this Google Colab, and means Google Colab server. What we can do is even we can do all these things in the VS Code. At that point of time, everything will be done on our laptop. Any questions?
So,
And
Surendra,
yeah,
here we are passing the parameters to mention about the images and the tables, and the text will be automatically considered. Is that
yes. Text is anyway the basic thing, right? So
okay? Okay,
it will create.
okay.
So if you only have text, then you need not to give all these things, right? These are the
Yes,
additional
yes,
additional parameters if your input document is having all those things.
correct.
Otherwise, providing all these things will delay your processing, right? Because if there are no images, maybe you are using no YOLO X kind of models unnecessary, right? So better to use these options only when you actually have these images and tables.
Okay.
See model, safe tensors, config JSON. I pray that it should not return exception.
Hey Surendra, I have a
Yeah,
question.
yeah.
Maybe it's not relevant in this context.
Mm-hmm.
See, in some company, they're fine-tuning the LLM to train their own content, right? Some
Mm-hmm.
company using this RAG to fetch their content.
Mm-hmm.
So, what is the exact difference actually fine-tuning this LLM and to using the RAG to fetch the content?
Okay, just give me a second. Sorry, my kid was there actually. Yeah, tell me, please. Please ask the question again.
No, I just need to understand the
Mm-hmm.
difference between this fine-tuned LLM and using the RAG
Okay.
to fetch the information.
Got it. See, fine-tuning means you are actually altering the parameters of your model, right? When we train a model, what we are actually doing is we are changing its weights, right?
Hmm.
When we have a neural network where we have different weights, when we say there is a 40 billion parameter model, that means that it is having 40 billion parameters, and once your training is completed, those parameters will have some value. Maybe the weight 1 will have 0.002 value, weight 2 is having some different value. Okay, so when you are doing the fine tuning, you are again altering those weights in such a way that your model will get tuned to your data of your own company. Okay, let's say you have a lot of content of your own organization. So what you can do is you can take any model and you can fine tune it according to your own data. Okay,
Hmm.
your company data. Then it will be able to answer the questions based on its training data. Okay, then it will be aligned to your company data or your domain data, right? Maybe your is a legal company, then you will take all the legal documents, you will create some training data out of it, and then you will train your model so that it will now be able to answer all the legal domain related questions. Okay, that
Okay.
makes sense. So in this process, what you have seen is, what we are doing is we are collecting a lot of data, right? Now you have to clean this data, you have to prepare your data, you have to procure some hardware to host your data, to host your model, and then you have to train your model, right? So this exercise is usually very costly. Okay, and
Mm-hmm.
end of the day, after doing fine tuning also, let's say over the after 6 months you will gather some more data, right? Now you
Mm-hmm.
need to do it again. Now you need to align your model again with the new data. You will do again some fine tuning. So
Mm-hmm.
usually industries are not going with this fine tuning thing. Rather, they will go for the RAG, right? What will happen?
Mm-hmm.
They will vectorize their data. If there is more data, that vector database will also vectorize that data also. And then it is cheap also, right? You are not doing anything. You are just taking your data and you are creating embeddings out of it, and you are using the large language model. So 80-90% of the times people are using RAG. So there is, very low cost in this particular method. Fine tuning is also not foolproof. Maybe you do fine tuning and let's say you are not achieving the results which you are expecting, then what you will do, right?
Right.
And maybe after some point of time, after 1 year, there is an other model which is very good model in the market. Now, how you will switch from your old fine tuned model to the new model which has very good reasoning capability, let's say, right? So but if you are using RAG, then you can switch your LLM, right? You can change your
Right.
large language model. You can use multiple LLMs also. You are not dependent on one large language model, right? And you are
Mm-hmm.
just using the APIs. That's it.
Mm-hmm.
So,
And
mm,
yeah, I got it. Okay.
mm,
See, when we using this kind of Python libraries or some other libraries, so
mhm,
as you mentioned, so there are a lot of libraries is deprecating, right?
mhm.
So because every month they are releasing new
Right,
libraries.
right, right.
So today it will work, tomorrow it won't work. So how
Uh,
we can avoid this kind of things? We have to keep monitoring this.
no, no. I mean,
Uh,
see, when you deploy your production system, you already know, right, on what versions your system is working right now, on what versions you have tested your system, right? So maybe you are using LangChain 3.0. If it is tested on 3.0, you will take that system, you will deploy in the production, and you will not change it, right? Why you will upgrade it to 4.0? Even if 4.0 is out, LangChain 4.0 is out in the market, why you will switch to 4.0? Or why you will do pip install LangChain? At that point of time, you will just do pip install LangChain equal to 3.0,
mhm,
right? So you need to keep a track of all the versions on which your system has been built, and you have to keep it, in your requirements.txt file. Or maybe at the time of deployments, what you do is you containerize your application, right? You use EKS, Enterprise Content Management System. You deploy that particular image in that, and then you use it. Okay,
mhm.
which has all the dependencies and everything in the container. Okay, this we will talk more in our future lessons.
Okay.
Okay. So when we do pip install any library, then it will by default install the latest library. So sometime it works and sometime it does not work. If any other dependent library has changed, then it will fail. So we should always make a practice that we just use the desired exact library along with the Python. All right, Python version also make a lot of conflicts.
Mm,
Okay, so this fortunately has worked. Now what it has done is it has created these chunks. Okay, the return of this method is chunks. Now we are having different chunks. Let's see what are the different type of elements. So this is a small loop. This is like for element in chunks. This chunks is having different objects. We are calling one object as an element, and we are just seeing what are the different type of elements in it, unique type of elements. So The email address is one of the element. Figure caption is one element. Footer is one element. Formula, header, image, list items, narrative text, table, text, and title. So what this library has done, it has created lot of different type of elements out of the input PDF, and these are those different elements types. Email address, and where is our PDF? Right? It may have some email addresses. So it has recognized this is an email address. So it has created one element out of it. Okay. It has seen there is some text. So it has created one element out of it. Okay. And then introduction, this is the text and images and things like that. And if I see how many different such elements are there, 217 chunks have been created. Okay. I was expecting less number of, oh no, fine, it's fine. So 217 different chunks have been created. Okay. Now what I will do is I will uncomment this piece of code. So what this code will do is it will decide our chunking strategy, which is by title. So when we define that, what it will do is initially it has created 217 different chunks, different elements. Now when we say group it by title, so the purpose is that, let's say this is my title, modern model architecture. So when I say my strategy is by title, it will combine those elements which are similar in nature. Okay, it will club all those elements which are falling under one title. Okay, encoder, decoder, table, and all. It will group those elements. Okay, so let me run this again. So this time 217, and when it will group it, what will happen? The number should decrease because it has grouped similar elements by title. The elements which are falling under one title will be grouped together basically, so that we can have context uh, under one title to be same. Let's see how much it
So in
creates.
this case, it won't be like text, image, and all different.
Yes, yes. So it will create, I think, one composite element which will have all the other all the similar elements inside it. Let's see actually. So these 217 elements were of, maybe 10 were email address, 20 were figure captions, 30 were footers, 20 were formulas, and the total sum was 270. And these are some overlappings. Okay, maximum character of when we are creating the elements by chunking by this strategy by title, what we are saying is the maximum characters in that particular chunk should be 10,000. Combined text under n characters 2,000. Okay, new afters n characters 6,000. So some kind of configuration which will make sure how many elements should be clubbed together. The limit of those actually.
Where we can refer this code actually?
So this has
Is there
been,
in
yeah, I mean, if you go, there are, I think this I took long back from LangChain. Okay, LangChain. Even this LangChain is having unstructured .io as a loader also. Okay, so what you can do is instead of using this library and installing this library, they have also exposed these providers as a loaders, just like we have PyPDF as a loader, right? So they also have this unstructured.io as a loader, which will use unstructured library under the hood. But I use it directly because by that way we are removing one layer of abstraction, right? So now we can look at the different methods and the different options out there. So Few months back, I took code from LangChain library only. This code is from. So all these LangChains and alls have also are there on the GitHub. So if you go to the GitHub now, they have their repository of the code. So that also you can mention. Let me search it out again and I will share the URL, whatever. Pip install LangChain unstructured. Extracts clean text from raw source like PDF and Word document. This page covers how to use unstructured ecosystem with LangChain. This is the GitHub library, right? So I have taken it from somewhere from here. Test unstructured. They also used the same PDF. Okay, so you can explore these also. They have like a lot of things. No one, write all these codes from scratch.
Hmm.
Reliance.pdf or need to search. Is it okay? So this is done. This time you will see the element is only one composite element. Okay. Actually, this also should have one more element of table, which is, I don't know, somehow it is not coming. Okay. But ideally it should show one table element also, right? So right now this is just showing the composite element. Let me see the chunks. So there are just 12 chunks basically now. Okay, from 2017 we have reduced the number of chunks into 12 because we have grouped the similar chunks into different composite elements. So let's say I take the chunk number 3. Now we have 12. If 3 means 4 chunk, this fourth chunk is having title, narrative text, footer, these two images because they all are coming from under same title. Okay. So here what I'm doing is elements equal to chunk 3. The fourth chunk we are taking and we are taking the metadata, original elements. These are the elements in chunk fourth. And if we iterate those elements and if we see if that is of image type, right? So every composite element is having different other elements. For example, this is having two images. Okay. So what I'm doing is I am just trying to find out the images. Now this chunk images object is having all the images from this fourth chunk. Okay, so if I convert that into a dictionary, you can see this is the type of image, this is the element, this is the scale dot project dot product attention, and this is our base image base 64 representation. Okay, this is the result of this particular option where it is this one. No, this one. This one, sorry. Okay, with the help of this option, what we are doing, we are also converting our image into base 64. So in the metadata, we can see that the image element is having image and all other metadata and also the base 64 representation. We can also separate text elements into tables, text and images. This was coming actually 0 yesterday also. So with the help of this base64, this function, we have written this function to display the image. Okay, whatever image which we took out of that composite element, we can also display it. So you can see how beautifully it has extracted this image out of it. Okay.
Can we get doc ID also?
Yeah, I mean doc ID we have not created yet, right? We will create it.
Okay.
Okay, doc ID will come somewhere here. Okay, so right now we have not even sent our elements into the LLM. Okay, we are just trying to club all the elements into these three groups: images, tables, and text. So somehow what I was saying is this my table is coming empty. I'm not sure why. I was trying yesterday also. This is coming as 0. It should have taken out images also. Then we would have one collection of tables, and then we have one collection of images, and the third is the text. Okay. And the next step would have been to summarize all these things. Okay. You are getting what I'm doing, right, guys? Or you are lost?
You are just extracting the information, right, from the PDF.
Exactly. After extracting the information, what I'm trying to do is I'm clubbing images together, I'm clubbing tables together, and I am clubbing text together. But
Mhm.
somehow this table output is 0. I don't know why. So this I need to try again. Right now we are just having text and images. Okay. Now our next
So
step is, yeah.
one question: this grouping we did right on based on the title and all, just
Ha.
so that is kind of tuning, or
No, that is not tuning because we have to send these different elements to the large language model, right? So that we can create summaries.
okay.
So we don't want to send them all together because images we want to send to the multimodal model, right? Our OpenAI. Whereas tables and the text can be sent to the Grok models. Okay? So,
Okay, okay.
so we want to segregate them so that we can create respective summaries from these models. Okay?
Okay.
One
On this,
question.
hmm,
This you are extracting this information using unstructured or LLM?
unstructured.
Unstructured.
These elements are taken from the unstructured library.
Hmm.
Okay?
So then you will pass it to the LLM to.
Yes, yes. So that is why I'm installing this Grok and I'm installing all the things which we used to do in the past. So this is the prompt which says you are an assistant tasked with summarizing tables and text. Given a concise summary because tables and text will be done by our normal non-multimodal LLM, right? So they can be given together. And so this is the our prompt. We will send the element, the table or the text chunk here. And this is our prompt and this is our chain. Okay, we are using Llama 3.18 billion instant. You can use anything, right? Any Llama model. So as I said, these tables.metadata.text as tables. So these tables are actually represented as HTML elements. So, right, just like image has one metadata as the base64 representation. Similarly, these tables are actually converted into HTML documents. Okay, tables HTML and table summaries. So I have passed my information and this table summary is coming empty. This is what I'm saying. I need to fix this one. And if I go to images, where is my text summary? This is my text summary. Let's have a look on text summary. So this is my text summary. The paper attention is all you need. Proposes a neural network. Okay. It has pulled those nicely.
For the entire PDF, it is summary.
Yes, yes. This is a list
Or
of
for the
some.
chunking strategy, like you mentioned.
Mhm. No, this is for entire PDF. I think text summary, summarized text, summarized. It has sent the batch. We are using the batch. and we are sending all the text elements. The list of text, right? So we are sending them all, and then it is giving me, when we send the batch, what do we get? Do we get the list or what? List. Okay, so this is list of all those summaries. Got it? So it is not summary of one text, but the entire list of text elements which it created all together, because this is a list basically. Similarly with the images, for images we have to use our LangChain. Describe the image in detail. For content, for context, the image is part of a research paper explaining the transformers architecture. Be specific about graphs, such as bar plots and etc. And we are using GPT-4o mini because this is the most cost effective. It is cheaper than 4o, cheaper than 4, and it is comparable to 3.5 turbo. So we are sending all those images. That's why it is taking time. It took 30 seconds. We sent all the images, and now we have got the image summaries. Okay. Okay, guys, this 4o mini is a multimodal model. So we could pass the list of images which we extracted from our PDF, from our research paper, and we passed all those images in one batch by using chain.batch function. Just like we have chain.invoke or chain.stream, we also have a chain.batch function where we can send a number of images in one go, and all the image summaries are now captured in this list. If I display, if I take the first element, let's first see the what was our first image. Okay, so this is our first image, and then we will see, so this is the image of our transformer architecture. Now let's see what image summary it has created for this one. So this is my image summary of first image. Okay, it says the image depicts a schematic representation of transformer architecture commonly used in NLP task. Key components. Okay, superb. Key components, input output sections. At the bottom there are two boxes labeled input embedding and output embedding. Input embedding and output embedding. So now you can realize the level of these summaries. Okay, by sending this image to the GPT-4o mini, what it has created is it has created the summary of this image. Now if we ask any question on this image, ideally what we are trying to, the user will be asking, let's say, question on the multi-head attention, and let's say there is no text in the entire PDF with multi-head attention, but it is only there in the image. Then also our chatbot application will be able to answer our question. So the level of summary is, I think it's really superb, isn't it? So it is going up to the depth of each and every block. It is saying there are, in the input and output sections, at the bottom there are two boxes labeled input embedding and output embedding, indicating whether the input data centers and blah blah blah. Positional encoding. It talks about each and every component. Each embedding layer has an associated positional encoding, suggesting that position information is added to the input data. Is it good or not, guys? I mean, I was really impressed by these kind of summaries from the GPT model. Okay, so likewise, it will create summaries for each and every image. So if I print that, this is the same. Okay, we can have some other summaries also. So for this image, this is the summary, and then what is our next step? We are now here. Okay. The next step is load and summarize to vector store. So what we are using? We are using Chroma database. And what is our document store? That is in-memory store. And this is my OpenAI embedding. This is my multi-vector. This is again a LangChain function, which will give me a retriever. Okay. This is Chroma database. This is in-memory store. This is my document. The same document which we used in the RAG class, right? The different chunks are represented as a document object. OpenAI embedding and multi-vector retriever. This is the Chroma. Collection name is multimodal RAG. Embedding function, OpenAI embedding. This is my vector store. And my document store is like in-memory store. This in-memory store is coming from LangChain also. And my ID underscore key is doc ID. So doc ID is the our association of our image with the summary or element with the summary. This is the retriever. I will use multi-vector retriever from LangChain. Vector store parameter is the vector store, which is Chroma database. This doc store is our in-memory store, and ID underscore key is our ID key, which is the document ID. All good? Superb. So now we have our all these things ready. Now we have to load the summaries and link to the original data. So how we are going to do? We have written our custom function. Okay, what it is doing is uuid.uid for in text. Okay, so whatever text we have, if we have, this is the list of text, right? So whatever text we have, we are looping and we are associating the doc IDs. Okay, so this is the list of those document IDs. These are my summary text. This is the LangChain document. Page content is my summary. Metadata, I'm explicitly passing my doc ID. Okay, for I, this is my text summaries. So I'm iterating to the text summaries and I'm giving them the different doc IDs which I have created. Okay. All in all, I'm passing one text element and I'm saying that this doc ID should be associated with this particular text embedding. Okay. And like that, I'm iterating through all my elements of the text and I am associating my uh, summaries and doc IDs. Okay. Retriever dot vector store dot add documents, and now I'm adding all those summary text into my vector store. And at the same time, what I'm doing is I am sending document IDs and the associated text. So the original text is going in the document store and only summary text is going into my vector store. Okay, this text is associated with my doc IDs also. Okay. This I had commented yesterday because this table part is not working. Our table elements is coming 0. So this I had to comment. And similarly, just like we did for the text, if we have 10 images, for each image, there will be one unique ID. I will create, I have the summary of the images also. I will be sending my summaries into vector database and images into my doc store. While sending images, I am also passing the respective image IDs. And for the vector store, the image IDs are associated in the metadata. Okay. They are together and they are together. Okay, so we are done. Okay, we have put our original elements in the document store and the summaries into my vector database. Now the retriever, how we will do the retrieval? We already have the retriever. This is my retriever, which is again from the LangChain. So I will simply ask, what is attention mechanism? I have got some documents in my response. This is my response. If I iterate, I will get these documents, PED, PED, PED. What is this, by the way? Okay, so I have not created the rack pipeline. I was just testing this particular thing, whether my retriever is working or not. Okay, now I will create my rack pipeline. I answered the question based only on the following context, which can include text, tables, and below image. This is my context. This is my user question, prompt, text, prompt template, type is text, text is prompt template. Okay, same sort of code. This is my dictionary. This is my runnable lambda, build, prompt, chat. Uh, this is my model. Okay, this is my output parser. So let me run this. So with this, my chain, if I ask the question, what is attention mechanism? What it will do is it will tell me the attention mechanism. Then I asked again other question, change with the sources. What is the attention mechanism? This time, response specifically scale dot. This also shows me the image. This content is not clean. Okay, I think you have got the idea, right? Maybe I will fix a couple of things here and there. But you can see in my response, I am along with my some text, right? Along whatever question which I asked, right? My question was what is attention mechanism? And then I was able to retrieve the text response accompanied by there is also an associated image out of it. Okay, so this is what the multimodal RAG is. My information is coming from image as well, and my image is also coming in my output. I mean, does it make sense somewhere at high level, guys?
Yes, for high level, yes.
Yeah, I mean,
Yeah.
yeah, I mean, couple of things since the couple of things are not working, even I'm not enjoying giving the last piece of this section. So let me fix this. But I think you got the idea, right? How we are doing it.
Yes.
So these we cannot do without OpenAI, like for image, correct?
No, I mean, as someone was asking, right, we can use the llama models as well. Llama, you have to use the vision model basically.
Vision model. Okay.
Yeah. Okay. So what I will do is next time I will fix this error also so that our table will also come, and then I hope you will also enjoy the session. Meanwhile, you can just go through the theory part, and I will also share the code as well. You can just experiment with it. Okay. And I think you have got the idea how the content or the multimodal data is taken care. Okay. And I will also push that code of that onboarding assistant. Okay. So you want me to push that code or you want to first try yourself, guys?
Okay. Surendra, one general question.
Mm-hmm.
It's not. See, I'm just asking this question in enterprise content management perspective.
Uh-huh.
So in ECMS, we have a lot of billions of documents.
Mm-hmm.
So how we can implement this RAG effectively in this domain?
Yeah, good question. On So for that, I think you need to first vectorize your content also, right? You have to create a
Yeah, because
pipeline,
it's
huge content.
it's a huge content, right?
Mm-hmm,
So anyway, we are using RAG is mainly for searching searching the documents and contents
mm-hmm, mm-hmm.
predominantly, right?
Right.
So in the
One.
ECMS
Mm-hmm,
landscape,
mm-hmm.
so I think since we have a more documents, size of the documents is huge. So will it possible to implement this RAG effectively?
Now I understood your question. Since the volume is too much,
Mm,
then I think what you can do is maybe you can start from, for example, in IBM FileNet we have different object stores, right? In Documentum maybe it is called Docu Store or something. Maybe you can take just a small chunk of those documents which are altogether different. Let's say if you have different object stores for invoices, one separate object store, or in POs, some different object store. So maybe you can take just one part of it and you just do a POC that if you take that particular chunk or part of your document instead of going for the full volume, just take some part of your documents, vectorize it, and then just try to show the business what value it can bring if they expand it to the entire chunk of the entire volume basically, right? So
mhm,
that could be one thing. Or second thing, I mean, it's not like that you always go for the RAG. I mean, there are some other applications also, right? Other things also, like maybe once you are searching your document, it is going into your database, it is searching the PO number, whatever the user has entered, then it is also pulling your content file from the file systems. And then while showing it to the user, if you could pass it to your large language model so that it can, convert that content into more, it can, put some more sense to the content. Maybe it will pull some information like entity recognition, right? It will club all the places, or all the dollar value. I mean, what I'm saying is maybe you can manipulate the content of your file which you are going to show to the user, and maybe you can show it in a different way, right? If user has to go somewhere, and in the content, if it is looking for certain things, right? Maybe he's looking for the places, then maybe you can extract all the places with the help of LLM, and you can show it differently, that these are the different places which are referred in this document. Okay, if those are medical documents, or maybe some diagnosis, maybe some data, you can show in a tabular format by using LLM. Are you getting the gist? I mean, what I'm trying to say, on the fly, you can do some
mhm,
representation kind of thing.
mm.
I can think more
Anyway,
on that.
I'm keep thinking about this, but
Mm-hmm.
I just put you
Mm-hmm.
in front of you. Maybe I'll get some suggestion. That's why I
Mm-hmm.
put it this question. Okay, let's
There
see.
is.
Because when we go for RAG, it seems we cannot go for big chunk of documents, right?
Mm-hmm.
So we can try out with minimal documents.
Yes, yes, you
That
can
is
create.
one case I am thinking, but
Yes.
going with billions of documents, it seems it's very tough for you, because already we have separate, say, SQL
Mm-hmm.
database, but
Right.
again we have to use this another vectorized
Mm-hmm. So
database.
I think I think what you need to do is first you just talk to your business and your client, and since you are supporting those applications, first try to find out the pain points of your application as of today, right?
Mhm,
What are the different problems or difficulties your business is facing? Once you know that, and keeping this GenAI in mind, then you can think of certain solutions, using how you can use LLM to get rid of those problems. So go by that route also. Try to find
mhm,
out the pain points of your business, what they are looking for, what they will be, in how they will be happy if you, what kind of data and how you can show the data so that it will make more sense for your business. right?
I think
Maybe.
one use case I'm thinking this, instead of
Mhm,
this go for big volume of documents, in case in the
mhm,
application perspective,
mhm,
there is a problem to analyze the logs, right? So
mhm.
we can take this logs and provide this LLM to get, I mean, um, get the specific the errors,
Errors,
analyze the
yeah,
logs.
yeah, yeah, yeah. That is also
That's
kind of
one,
entity, right?
yeah,
Whatever logs which are
NDTS.
being generated, it will see where there is an error or there is, and
Yeah, warnings.
end
We
of
can
the day,
segregate and
end of the day, after a month, maybe you can use LLM to generate a report where it will show there
mm,
90% problems were, related to the database, 10 were maybe because of your application server. It can generate some data like that
reports.
also, reporting kind of thing also. So that's sense. So always go behind the reasons or the pain areas. Then I think you will get some solution.
Mhm.
I
Okay,
I
it's
can
good.
help you connect with Anand. So there is Anand in this group also, in this batch one. He is a
Mm,
FileNet architect, and he's also working on content management plus this. Gen AI.
mhm.
Okay, so you can directly ping him. Okay, I will.
Yeah, sure. Thank you.
He can give you more because I left content management a couple of years
Very
back.
long back. Yeah, okay, okay. Understood, understood.
Yeah.
No, because I'm keen to implement, provide some solutions to my
Hmm.
managements, but
Hmm.
I don't get the proper use case to implement it. So anyway,
Okay, let me also think. So,
yeah,
what kind of business is your client
it's a
doing?
ECMS only.
No, ECMS is fine. What is the business basically, or which domain your business, your client?
It's a power plant.
Sorry,
Power
power
plant,
plant.
power plant.
Power
Yeah,
plant. Okay,
yeah.
okay,
Okay. So just let me know if you get any ideas or some
sure,
use
sure, sure.
case.
Yeah, yeah.
Maybe it will be good to brainstorm on this.
Mm-hmm.
So can I add few points if you have the PowerPoint or an construction environment, right?
Yeah, please.
So power plant means like they have like every second they have like readings from the devices. So those readings can be captured from the any hardware device and we can place it into the RAG or vector database and they can report few reports.
Mhm.
So why? Because like I have a similar, I worked like previously with an aerospace industry. Like they also generate few parts. So for that, right, it's an huge machinery. So for each machinery, like there will be a maintenance and predictive analysis. For that, we need to collect lot of data for each and every second, how
Mhm.
the machinery is behaving, and we need to place few sensors and we need to collect
Yes,
the data.
and so for
Yeah.
that, we have to use this some machine language, right? So read
Yeah.
sensors.
Yeah, that is one point. That is entry point, and after that, right, we need to process the data with help of a RAG vector database
Mm,
or big data. We can configure those, and we can push it onto the algorithms, large model
mm,
algorithms, and we can land it onto the reporting side. So there
mm,
we will integrate with the Tableau and all the reporting tools.
mm.
Right. So this AI is like it will be help us into segregate the data.
Right.
So here it can help us. This is like very high level. If there is any specific use case, then we can help you out.
Sure, sure, sure. Yeah. I think
Siren,
this kind of discussion, I think will it will be good
Exactly,
to,
exactly.
I,
Yeah, since now we have very good understanding of how this Gen AI works, the
mhm,
architecture, this vector database. Now you should all be thinking about, maybe you all guys can start doing some project of your own, right? Maybe some kind of POC which is more relevant to you. So you all can start doing some personal project, and maybe I will help you out the way I could, right? but you should start working on your personal project. I mean, this is what I think. Think of a scenario which suits more to you and your business, your client, and then start working on that. Okay, and start discussing all these things in the group also. Try to give some context, what kind of business your client is doing and what is your domain, and then I think other people will also jump into it. Okay.
Good.
Sudhir, I have a question on this RAG
Mm-hmm.
discussion. So once we get this data onto the vectorized database, right, then we can push it onto the web application. That is the next step, right?
Yes, yes. Web application will see web application will be our front end, right? So
Hmm.
whatever users will be asking a question, that question will be passed to this vector database, right? We will create that chain, right? We will
Yeah.
create those chain. The question will be passed to the chain. The data will come out from the vector database, and it will run and it will show the response to the user on the your web application, right? The interface basically.
And so the end of the day, like we are porting this data to the chatbot.
Yes, yes, yeah.
Okay. Okay.
So
And you
that.
said,
Hmm.
you said you mentioned right initially in this
Mm-hmm.
session, you have configured your Linux environment to the uh, to your environment, right?
Linux environment in this session.
Yeah.
In the beginning, I was saying this Google Colab is actually this Google platform, right? Which we
Mm-hmm.
are using. We are installing the library. So they are not getting installed on our local machine. Rather, they are getting installed on that Linux platform, right?
Yeah. Yeah. So you're using the environment from the Google Colab, right? I have an
Yes.
Linux environment.
Mm-hmm.
So can I configure that Linux environment to the Google Colab, or like I should use at the local environment?
Mm. No, I mean, you have both the options, right? If you want to work on Google Colab, you can use it. I'm just saying the hardware which Google Colab is using is on the Linux. So those
Hmm.
directory structures and everything looks like as we are working on a Linux machine basically. Okay, if
Okay.
you do it on your local Linux machine or local Windows machine, yeah, I mean that is fine. That will everything will be run on your machine itself. Right now,
Okay.
everything is running on that Google shared
Hmm.
session. Once we close that, our session and our data is erased, right?
Hmm. 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 If it is local, it can store in the
Yeah,
local.
yeah, yeah. Local means your own. You can.
Okay. Yeah. Why? Because I created my local environment. So in
Mm-hmm.
the laptop,
Mm-hmm.
as of now, it is working fine. So
Mm-hmm.
just I needed
Yeah, yeah.
suggestion.
This
So
also unstructured also you can do locally. I did it a few months back, 3 4 months back. So I will also do it again. Okay.
yeah,
I also need to see why the tables are not coming. So yeah, maybe we'll discuss about a little bit more on this one next session also.
sure, sure.
Okay.
Yeah,
So Surendra, you will be sharing the code today?
Yeah, yeah, I will share it. Okay. Whatever
Yeah,
in in
this
in
version you can share.
yeah, I mean in whatever shape it is, I will share it so that you can
Yeah,
also parallelly see why it is not coming. Okay.
right.
Hey, Surendra, one more thing. This
Mm-hmm.
the last week, this Streamlit code. Could you please share it?
Yeah, I will share both. I mean that also,
Yeah, thank you.
which you can use to create a Streamlit application, and then you can change your logic and your everything you can change little bit here and there, and then it will be specific to your use case. Okay. So that will
Yeah,
work as a framework for you guys. You can
right,
play
right.
I mean you can play around with it and you can show it to your managers, your stakeholders.
So, Surendra, one last question.
Mm-hmm.
Like in interview, they ask like, how do you deploy this? Like, let's say we
Mm-hmm.
have created this over Visual Studio or somewhere.
Mm-hmm.
So how to, I mean, over GitHub or something. How do we deploy this?
So this application, I mean, it has various ways, right? One is you containerize your application. Other is you expose it as a fast API, as you did, or maybe in Azure there is something called Azure Apps, I think, right? Azure Apps. So there also. So I also do need to do a little bit of homework on that as well. Okay. So yeah, I mean, let me create some content on that and then I will be able to help you more on that. Okay. I once deployed on this Streamlit. Streamlit also provide this environment, this cloud environment where you can directly, put your Visual Studio code. Okay. I think let me check whether that application is running or not. The application was chatting with. Mm, So this Streamlit code you can directly deploy on your this Streamlit cloud. Okay, Streamlit provides a cloud environment as well.
And this is the standard that is followed even in organized.
No, I mean this is not a standard. This is just to get you a feel. You know how you can deploy your application. This is not the I mean proper way. This is just for demo kind of thing. So if you put any website here, this is some village. Okay, so this is some village. Okay, so it has all these informations. So I have just provided this URL to my application, and I can talk to his. Okay, so this is a small village in Makrana Tehsil and blah blah blah. Okay, so this application is on cloud actually. It's not running on my local machine. So you can use this Streamlit cloud just to do this deployment. This one. Okay, sign up and then just. Okay, so you can simply click on create app, connect to GitHub. You need to put your code in the GitHub, and then I think it will connect with the GitHub. You just need to give the URL of your application, and then it will deploy it. I mean, very simple process.
Okay.
Okay. So yeah, that is it for today. So I have two action items. I will share the code of that onboarding application. I will share the code, the Google Colab code for this multimodal also, and we'll share the recording also. Okay, all good. Anything else, guys, before we wrap up for today?
Okay, Surendra, thanks.
Thanks, everyone. Thanks, guys.
Thank you.
Bye. Bye.